Hello everyone. Hello everyone. Here are some questions I have for us under circuit geometry that I would like us to treat today. And the first question here follows a theorem that says an angle, that is an angle that lies between a tangent and a chord, is equal to the angle subtended by the same chord in alternate segments. That is, this is a chord that makes an angle with the tangent, and this chord makes here a segment, and therefore it makes here and here also another segment. This chord makes here, they make them segments, and the segment that alternate this segment the segment that alternates this segment here is the segment that's in front of it, that is the segment that alternates each other, more like a z segment, and the angle subtended by the segment will be equal to the angle this chord has also. Therefore, in this first question, our theta will be 56 degree because they will be equal to each other. Adding being, we have an angle here now. The angle we have here will be equal to the angle we have here also, because they will be alternating each other. And to the second question also probably, let's say, wants to follow the rules, but there are two ways we can actually use in solving the second one, because this is not a chord, it is a diameter. It is not a chord, it is a diameter, and this diameter here is touching the tangent under here also. And there is another theorem of tangent that says the radius of a circle at any point makes 90 degree with the tangent. And if we are to consider from the center of the circle here to this tangent here, we consider this line a radius, because this whole line is a diameter. Therefore, if this line here is a radius and it should make 90 degree with this line, therefore the angle inside this triangle here will be 90 minus 78, which will be 12 degree. That is, the angle here will be 12 degree. If the angle here is 12 degree, there is another theorem that says an angle subtended by a semicircle is 90 degree. An angle subtended by a semicircle is 90 degree. That is, the angle here will be 90 degree. Therefore, our theta will be 90 plus 12 plus theta equals to 180 degree, because the sum of angle in a triangle is 180 degree. Therefore, we will have theta plus 102 to be equals to 180, and our theta will be equals to 180 minus 102, which will be what? Yes, 78. You can see that this solution here proves that whatever angle subtended here will be equal to the angle that is here also, because the 78 degree we have here is equal to the one we have here. Therefore, we prove that the theorem we used in the first one is actually correct, and it is still applicable to this one. We can just say this 78 is equal to the theta here. And those are the two ways you can use in solving it: by following the first one and get your answer correctly, or trying to prove if you are correct with the theorem. And that brings us to the next one here also. We have the same rules, say let's say similar rules in this place also, whereby the 72 degree we have here will be equal to the angle here, which will be 72 degree also. And for us to get our theta, we can see that this is a straight line, and our theta and 72 are the two angles we have on the straight line. Therefore, we can say theta plus 72 degree equals 180 degree, and that angle on a straight line. Therefore, our theta will be 180 minus 72, and our theta will be what? 108. Our theta will be 108 degree. And that's all for today. This is just a simple, small question to test the theorems of tangent we have in circle geometry. And if you are willing to learn the full theorems on a circle geometry, please don't hesitate to subscribe to this channel on your notification bell, as I'll be dropping all the theorems we have on the circle geometry. And don't forget to like and share. Thank you very much.